We're now going to look at radians when we're solving trigonometric equations. So in order to do this example 30, we need to be familiar with a sine graph, but where the angle measure is in radians. So we'll be familiar with what it looks like if we were to do a graph for sine where it was measured as in degrees. So that would be 360 degrees there, 180 and 270 and 90, and it would go between plus and minus 1. So if we were to do the same thing but where radians was the measure, then we actually get these equivalent points are pi is the same as 180 when measured in radians, and 360 is 2 pi, and actually 90 is pi by 2, and 270 is 3 pi by 2. So we can draw the graph, which again goes between plus and minus 1. It's just that we're measuring the angle in radians, but actually the size of sine of the angle still goes between plus and minus 1. So we can mark these points on here and draw the same graph. And so then what we can do is we can find our working angle just as we would have done if we were using it in degrees. So we would set our calculator to radians mode, so it must be in radians, and we would solve this one by saying, well, if sine theta is equal to a half, then theta is equal to sine minus 1 of a half. If you put that in, what your calculator is going to do is give you the answer that is nearest to 0. So you do the first solution to this equation, and it will give you that theta when measured in radians is pi by 6. So that's this point here, pi by 6, and if we project it up to the graph, we'd find that this was a half. But in our range 0 to 2 pi, if we project across, we can see we actually have another solution, which is here. And because of the symmetrical nature of this graph, this point can be found by taking away pi by 6 from pi. So that's our first solution, and our second solution would be pi, which is this point here, minus pi by 6, which means that we will get 5 pi by 6 as our other solution in this range, in the range 0 to 2 pi. So that's example. If we now look at example 31, so this is pretty much a similar situation to example 30. So we've got an equation involving tan, and so if we rearrange that, we can see that tan theta would actually have to equal root 3. So what we'll be doing is setting our calculator to radians again, making sure in radians, and theta will equal tan minus 1 of root 3. And what that will give us, according to our calculator, is that it's pi by 3. But again, that is just the first angle closest to 0. So what we've got to be familiar with is the tan graph. Okay, so the tan graph actually has asymptotes at pi by 2, goes through the horizontal axis at pi, has another asymptote at 3 pi by 2. And these are equivalent. If we were measuring them in degrees, that would be 90 degrees, that would be 180 degrees, and that would be 270 degrees. And then we're up to 2 pi, and that would be equivalent to 360 degrees. So if we draw the asymptotes in, and then draw the tan graph, what we'll find is it goes through at 0 and goes through at pi, and so the graph of tan would look like this. And the solution that we've got for root 3, which is here, is we've got pi by 3. But that's not in our range, because our range is actually between pi by 2 and 3 pi by 2. So we're looking for a solution in this range. So what we have to do is we can project along to the graph to find the next solution, and that would be there. And again, because of the symmetrical nature of this graph, we can see that any solution that we do find, we can find all the subsequent solutions by just adding pi onto it. So this next value here is given by pi by 3 plus pi. So we've actually got pi by 3 plus pi, and if we work that out, that will give us 4 pi by 3. And of these solutions, the one that's pi by 3 isn't in the range that we're interested in, so we can reject this one. So that's not in our range, and we want this one because that is in our range. And if we were to continue to look at the next solution, which would be up here, we can see clearly that's outside of our range. So this is the only answer that's the solution of this equation that's in the interval required.